Let's take some notes. So we're going to look at solving and graphing today, reviewing more from Algebra 1. Graphing is a huge, important part of mathematics. As you go farther along, you're going to graph more and more and more, so you need to be familiar with the basics. Hopefully you did a lot of graphing in your Algebra 1 class, straight lines and parabolas at the very least. But we'll go over some of the basics today. The coordinate plane. If you take a number line, which usually has 0 in the middle, positives to the right, 1, 2, 3, 4, and they keep going. Negatives to the left. And you make another number line, but this one you do vertically. Still put 0 in the middle. Positives are going to go up, and negatives are going to go down. And you make that 0 that's in the middle the same as this 0 that's in the middle. Then you have the coordinate plane. Since we have two number lines going on, we're going to call those axes. And we're going to label one the x-axis. That's going to be the horizontal one, the left-right one. And we're going to label one the y-axis. Our points are always going to come x first, y second. So it's always going to tell you the left-right movement from the origin, from the point 0, 0, and then the up-down movement from the origin, the point 0, 0. Zero on the x-axis, 0 on the y-axis. Call to the origin. Points come x first, y second. And then in this manner we can define any point in the plane. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. If we want to know what this point is, you figure out how far you moved in the x direction and how far you moved in the y direction. And then that from the origin, its x is 2, its y is 3, gives us the name of the point. So naming our points is very important. We got to know how each point in the plane is defined. We're going to talk about movement between 2 points, the slope of a line, in a minute. Hopefully this is all easy review for you. We're going to do some equations in 2 variables. So you're going to have x's and y's with an equation, an equal sign, adding up to something. Those can, of course, come in many forms. You can also have y equaling the x and the number. You can have x equaling y and the number. Equations in 2 variables just have 2 variables. Typically, we think of them in x and y, but there's no limit on the letters that you can use. You can use any letters you want. What are some other good ones? P and Q often get used, I guess. 4P plus 6Q equals 12. Things like that. Equations in 2 variables. We're going to probably stick to x's and y's for the majority of this lesson. You can translate if it's R and S. You can say one of those is going to be your y, one of those is going to be your x, so that you can easily convert between any 2 letters and the x, y things that we're going to talk about right now. A solution of an equation in 2 variables is any pair of numbers that makes the equation true. So if we take something easy like x plus y equals 3, if x is 1 and y is 2, that pair of numbers, the pair 1, 2, 1 plus 2 is 3, makes it true. That pair of numbers is a solution to the equation. Whereas if we took 5 plus 5 is 10, it is not a solution to the equation. So you have things that make the equation true, you have things that don't make the equation true. And of course, whole numbers are easy, but we could also have 1/3 for the y, and let's see, I want 9/3, so 8/3 for the x, because 8/3 plus 1/3 is 9/3, adding the tops over the common denominators, which is 3. So the point 8/3, 1/3 is also a solution to the equation. And this is one of the good parts about graphing, is that when you graph, you not only get all the whole number points represented that make the equation true, you also get all of the fractional ones, you get all of the irrational points, you get every single thing that makes your equation true. So graphing turns out to be very powerful for representing what the solution set of an equation actually is. We're going to start with linear equations, lines. The slope-intercept form of a line. Y equals mx plus b. Hopefully familiar from your algebra experience last year. M is your slope. B is your y-intercept. Slope, the letter M. Is how far you rise and how far you run in between any 2 points on your line. This fraction is always going to be the same no matter how far apart on the line the points are or how close on the line the points are, because fractions always reduce. You can take the same number out of the top and the bottom, and it'll reduce to the same fraction no matter what 2 points you pick on a line. There's an equation for slope. The change in y over the change in x. We got subscripts. Subscripts always throw people off. No big deal here for the subscripts. You gotta have 2 points. So point 1, you're gonna get some x comma y point. You're gonna have a second point, because you gotta have 2 points to find the slope in between 2 points. But doesn't it also come in an x and a y? So how are we gonna tell the difference between the first point and the second point? Well, we're going to subscript. We're going to put a number in the bottom right-hand corner that tells us that is the x and the y from the first point, where the other 2 numbers are the x and the y for the second point. That's all they do. And there's your formula for the slope between 2 points. So there's obviously lots of stuff going on here. I'm hoping you remember stuff from your algebra class that you studied, because we could spend a week on lines easy if you don't know anything. Y-intercept is where you cross the y-axis. And when I say where you, I mean where the line. It's a very good starting place. You get your y-intercept. And so here our B, well, I don't want to put that right there. Let's move that a little bit. Our B is 3, our y-intercept, where we cross the y-axis. Our slope is how far we rise over how far we run. So we're rising 1, 2. We're running 1, 2, 3, 4, 5. Now, I don't have many good ways to show you how I'm counting when I'm counting in the coordinate plane. So usually I just make those little bumps as a way of me showing you what I'm counting. Because otherwise, I just count. You hear, oh, the rise is 2 and the run is 5. But you don't actually see how I'm counting 2 and 5. So that's all those little bumps are, is me showing you how I'm counting to get my slope is 2 over 5. I don't ever actually put those on my real papers. No one does. But there's no better visual way I've found for me to show as a teacher to a student what I'm doing there. So the slope-intercept form of a line is how we write the equation of our line plugging in the slope, m, and plugging in the y-intercept, b. There's the equation of this whole line. So not only are we getting the point where the y-intercept is, the point here, 5, 2, but we're getting the fractional point that's represented here with 3 and 21/5. We're getting the point way over here. It's represented by the negative x and whatever that value of y is. We're getting the point where if you follow that line way over here, you also know what that point is. This equation defines every point on the line. That's why equations for things and the visual representation, the graph of them, is so awesomely important in mathematics. Whew. All right, so that was a lot of information. We're going to come back. We're going to work on some other stuff. Take a little break, grab a drink of water. See you in a second. All right, so we're going to solve an equation for y, then graph using y equals mx plus b. Solving means get y, since it says solve the equation for y, equals everything else, the mx plus b. So we're going to use our subtraction property of equality to subtract 3x from both sides. Simplifying that, we get 4y equals negative 3x plus 24. You can't combine the negative 3x and the 24 because they're not like terms. There's nothing to use the distributive property on. So we can't. You just write them next to each other. What's negative 3x plus 24? It's just negative 3x plus 24. We're going to divide by the number in front of y, dividing everything by 4. Using the division property of equality and simplifying, we have y equals mx plus b. So now it's easy to recognize what the m is, negative 3 over 4. And it's easy to recognize what the b is, 6. So when we go to graph using the y equals mx plus b, the b is the y-intercept, which gives us a starting point. It's the y-intercept, so the x is 0 because we're on the y-axis, and the x is 6. So putting that point on the graph to the right, the point is 0, 6. And then the negative 3/4 gives us directions. It is telling us how to move from that starting point. So from the starting point, we want to rise negative 3 and run positive 4. Slope is a directions, how to move from one point to another. So we're going to rise negative 3. So from our starting point, we're counting down 1, 2, 3. We're going to run positive 4. 1, 2, 3, 4. There's our new point. So if we do that again, most algebra teachers tell you to make 3 points and then find a straight edge and connect them to draw your line. Oh, but Mr. Algebra teacher, why do I have to draw 3 points? Because they asked you to. So, very common in algebra, you put 3 points on. Often your teachers are sticklers about putting arrows on the ends. You don't have a graph. If you're not telling me that that graph keeps going in that direction, be willing to compromise. Be willing to say, okay, if you really want those arrows on there, I'll put those arrows on there. If you want me to put 3 points on, I'll put 3 points on. It's not a big deal. If you fight the big fight and make it a big deal, all you're doing is making your life hard. Find out what your teacher wants and simply do it. It makes your life easier. But hey, if you want to make your life more difficult, fight your fights. You get to make those decisions on your own. So this is directly connected to making XY tables. Hopefully you made XY tables when you were in your Algebra 1 class. We could have taken the 3x plus 4y equals 24 and just picked x values. If I pick x is 0, I get 3 times 0 plus 4y equals 24. 3 times 0 is 0. 0 plus 4y is 4y. And dividing by 4, y equals 6. There's my point in my XY table. X is 0, y is 6. Lots of times then people pick 1. 3 times 1 plus 4y equals 24. 3 plus 4y equals 24. So I subtract 3 and divide by 4. 21 fourths? Ew. 21 fourths is a decimal. It's 5.25. So at 1, we got 5.25 here on our graph. You can hardly tell it's 5.25 because chopping those little tiny spaces into quarters is really hard to do. If you're super savvy, you pick numbers that make it easy to divide by 4. So you pick multiples of 4. So if we plug in 4, we would have 3 times 4 plus 4y equals 24. 12 plus 4y equals 24. subtract the 12, subtract the 12, 4y equals 12. Dividing by 4, we have a nice whole number, y equals 3. Oh, you get to pick your xy values, so you can pick values that give you nice whole numbers, you can pick values that give you horribly ugly decimals, you can pick the x values you want, but then you have to be able to deal with whatever y values you get in return. Can, of course, pick positives and negatives. Notice how 4, 3 is the point right there. 4, 3. If we had used our slope in the other direction and gone up 1, 2, 3 and over 1, 2, 3, 4, we would have the x value of negative 4 so we would get negative 12. We would add 12 to both sides. And divide both sides by 4. So adding 3 onto the 6, we get 9. Ooh. The point negative 4, comma 9. There's lots of interconnected things going on here. If you solved for y equals mx plus b first, and you got the y equals negative 3/4 x plus 6, then it makes it really easy to look at that and say, well, what should I plug in to make the fractional part here into a whole number? What's going to get the denominator to cancel out? Multiples of 4 make that denominator cancel out. So when you plug in 4, you would get negative 3/4 times 4 over 1, which is negative 3 plus 6, or 3. When you plug in negative 4, you would have negative 3/4 times negative 4 over 1, which then gives you a positive 3. So there's lots of interconnected pieces here. There's lots of different styles and things you can do. Hopefully you can remember back to the XY tables from Algebra 1. Hopefully you made a lot of XY tables in Algebra 1. As you progress in mathematics, you find very slick ways to graph things that don't involve making the XY tables, because lines are easy. They're straight, the numbers come out easy all the time, you don't have to think much about what XY values to pick. But as you go on, as we're graphing square roots, as we're graphing parabolas, as we're graphing rational functions, we graph a lot of different stuff, and the graphing gets more and more complicated to the point where you just can't do it by making XY tables. You have to have more sophisticated methods. But graphing is and always will be the representation of the XY tables. So, I mean, if you wanted to plot 1,000,000 points on your XY table, you could probably graph the most complicated graphs out there. You would spend all day just making your XY tables, but that's neither here nor there. So let's do some without doing the XY tables. Let's just solve the equation for y, then graph using y equals mx plus b. So we got a bunch of decimals. I don't know about you, but I don't like decimals. I'm going to immediately turn these into fractions. They're all 1 decimal place, which means they're all over 10. But if they're all over 10, can't we multiply everything by 10? Which is the same as multiplying by 10 over 1. So simplifying that, we would get 5x minus 7y equals 35. That's multiplying both sides of the equation by the same number, 10. And now I can subtract just a 5x. 5x and 35 are not like terms, so when you subtract them, you just write them next to each other. Negative 5x plus 35. Putting the 5x first, because we want it to look like y equals mx plus b. And we know that adding is commutative. You can switch it around. Negative over a negative is a positive. A positive over a negative is a negative. And there's our simplifying for the division property of equality. We have solved. Y equals mx plus b is what our equation now looks like. So we can identify that the m is 5/7. That's going to be our directions, our rise over run between 2 points on our line, which means we need 1 point to start from so that we know where to go. And so that point is the b, the y-intercept, -5. So -5 is where we start. Then we use our directions, rise, 1, 2, 3, 4, 5, run, 1, 2, 3, 4, 5, 6, 7. There's our second. But now notice, if we try to rise 1, 2, 3, 4, 5, and run 1, 2, 3, no, we're off the graph. Right? Our point would be somewhere over here. We no longer have a convenient way to put it there. What if we rise and run 5/7, but we run from a point that's the other way on the line? So now we want to keep that same rising and running, but we want to go rise -1, -2, -3, -4, -5, run -1, -2, -3, -4, -5, -6, -7. Because what's a negative over a negative? Isn't a negative over a negative a positive? So sometimes you got to run the opposite way of what you're thinking. A negative over a negative is a positive. So we're fine. We have all 3 points that we want. We're going to put our arrows on it because that's what our algebra teachers usually want us to do. And we go on to the next one. Solve the equation for y. Graph using y equals mx plus b. Alright, so we're going to subtract the 5x from both sides. 4y equals -5x plus 18. By the subtraction property of equality, divide both sides by 4. Y equals -5/4 x plus 9/2 by the division property of equality. So we look like y equals mx plus b. We know our m is -5/4 and our b is 9/2, which is 4.5. That's our starting place, 4.5. We're going to now use our slope, our directions, to tell us our rise over run. So from there, we are going to go down, rising -1, -2, -3, -4, -5. And notice how when I'm rising there, I'm going halfway in between, because if you're up a half and you rise down 1 whole unit, then you're still halfway in between the next two. We are going to run +4, so 1, 2, 3, 4. Connect our dots. Oh, we're going to do what our algebra teachers do and do it again. 1, 2. I gotta find my straight edge. Straight edge on the tablet's always fun. Sometimes my lines go all over the place. Solve the equation for y, then graph using y equals mx plus b. Subtracting 3/4 x, subtracting 3/4 x, negative 4y equals negative 3/4 x plus 8, dividing everything by negative 4. Y equals a negative, and a negative is a positive. Positive and a negative is a negative. How did I get 3/16? When you take and do your scratch work for a fraction divided by a whole number, you put the whole number over 1. When dividing fractions, give it a try. Flip the bottom one over and multiply, 'cause multiplying fractions ain't no problem. Top to the top and bottom to the bottom. So that's all I did. That's how I got 3/16. Negative over negative is a positive. So our m is 3/16. Our b is negative 2. So our starting place is negative 2. 3/16 is lame, because when we go down 1, 2, 3, we go over 16. So we can no longer count by 1, because we don't have enough room on our paper to count by 1s. So we're going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. Doing the same thing back, negative 2. Counting by negative 2 on each line. We want to rise 1, 2, 3. Run negative 16. Whenever you change your units, you have to write it down. You can't expect me to know that you changed units without writing down that you changed your units. And when you change units on one side, you gotta tell me what the units are on the other side too. Because otherwise I'm gonna think you changed all the units to 2. But really we just changed the x units to 2 and kept the y units the same. Write the equation of the line that has a slope of 3 and a y-intercept of 0, negative 4. Then graph. Well, we got to make it look like y equals mx plus b. They told us it has a slope of 3. They told us it has a y-intercept of 0, negative 4. So y equals negative 3x plus 4. So our m is 3/1. Our b is negative 4. So we're starting at negative 4. We're rising 1, 2, 3, running 1. Rising 1, 2, 3, running 1. Connecting our dots. Easy peasy. Write the equation of the line that has a slope of negative 2 and goes through the point negative 2, 7. So we want it to look like y equals mx plus b, most likely. But this point isn't b. It's the point negative 2, 7. So we're going to use something called the point slope form of a line. to get us there. The point slope form of a line comes from knowing just what the slope is and saying, okay, we're going to put in one of the 2 points but leave the other point alone. That way we can define what the other x, y's are if we know the slope. So we have a variable x and then the x from the point, -2. We have a variable y, and then the y from the point, y1 is 7. So y minus 7 equals -2x plus 2, distributing -2x minus 4. Distribute. That's property of equality, adding 7 to both sides. Y equals -2x plus 3. Our b is 3. Our slope is -2, which is -2 over 1. -2 over 1. And we go on to the next one. Whee! Sorry about that. So, now we're going to have our last series where we have to find the slope and then use our point slope formula to get our y equals mx plus b. So our slope formula is y2 minus y1 over x2 minus x1. We come in xy pairs. Doesn't matter which one you call x1, y1, and which one you call x2, y2. You will get the same number here either way. So -3 minus -5 over 4 minus 0 gets me 2 over 4, which is a half. We now know what the slope is, 1/2. So we can plug into y minus y1 equals m times x minus x1. The point slope form of a line, y minus y1 equals m times x minus x1. So y plus 5 equals 1/2 x. Subtracting 5 from both sides. And y equals 1/2 x minus 5. We simplified by taking x minus 0 and making it just x, and then we use the subtraction property of equality to subtract 5 from both sides, so that we can graph using y equals mx plus b. Our b is -5, and our rise over run is 1, 2. I did -1, 2 for some reason. Let's fix that. 1, 2, 1, 2. Way to connect the dots. Write the equation of the line that goes through 4, 2 and 8, 5. So we're going to do the same thing. y2 minus y1 over x2 minus x1. Our points come in xy pairs, so x1, y1, x2, y2. So our slope is y2, 5 minus y1, 2 over x2, 8 minus x1, 4, which is 3/4. We plug into the point slope form of a line. Y minus y1 equals m times x minus x1. So y minus 2 equals 3/4 times x minus 4. Distributive property of equality, 3/4 x minus 3. Addition property of equality gets us y equals mx plus b. So we start at -1. We rise 1, 2, 3. We run 1, 2, 3, 4. We rise 1, 2, 3. Whew, sorry about that. And we run 1, 2, 3. 1, 2, 3, 4. Play connect the dots. And our last example, x1, y1, x2, y2. Our slope is y2 minus y1 over x2 minus x1. So we get -9/2 minus 3/2 over 2 minus -1, which is -12 over 2. -12 divided by 2 is -6. -6 divided by 3 is -3. So we have a slope of -3. Y minus y1 equals m times x minus x1. Y minus -1. X minus x1. Distributive property of equality. Subtraction property of equality. So we're starting at 7/2, which is 3.5. We're rising -3, so we're rising -1, -2, -3, running 1. 1, 2, 3, running 1. Other fun things we did, all of this step, which I forgot to label, was our substitution step. So all the way back, I could have been labeling those. That's what we were doing there. We were substituting. Sorry about that. That's graphing. As you can see, we're going to work a lot with fractions. You have to know how to add and subtract fractions, multiply and divide fractions. Those 4 things are mandatory throughout mathematics. You see me doing it right here. My scratch work from that was 9/2 minus 1. I got to find my common denominators, so I'm making that 9/2 minus 2/2. 1 is 2/2. So I can subtract my tops over the common denominator. This is all scratch work off to the side. It's how you get what the number is, but it is not important to the problem whatsoever. I fully expect a lot of you are going to have to do a lot of scratch work for the fractions. This is that time where you're moving from Algebra 1, where you had a lot of leeway in kind of knowing what you were doing and having okay number sense, to where you want to be ready for Algebra 2 and be prepared to add and subtract, multiply and divide fractions, and be working on our number sense so that our lives get easier. Have a great day!